Hello again everyone and welcome in this video. In today's video, we will be covering multiple choice questions and theory questions for the second chapter of the IGCSE chemistry, the experimental techniques. Before starting giving answers for the questions, I will be giving here an overview about the titration technique and I will be talking about the reactivity series for the metals. So for the titration, it's actually a technique which is used to determine the concentration of an unknown solution. Unknown. Let's say that this is a base, for example. So to find the concentration of this solution, we will be using another solution with a known concentration. In this case, would be an acid. And in this case, the titration will be called acid-base titration. The set of apparatus used in titration is the following one. We use generally a conical flask and a burette. In the burette, we put the solution with the known concentration. In this case, it's the acid. And in the conical flask, we put the base, which is with an unknown solution. And we will be adding an indicator. So once the indicator change color, we will stop adding the acid from the burette and we can say that we reached the equilibrium point. So in titration, generally we'll be using a burette, which allow us to add small amounts of the acid each time until reaching the equilibrium point. Now for the reactivity series, you can see here that all the metals are arranged here from the most reactive until the least reactive, from potassium till platinum. Actually, we have potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, and platinum. And you can remember this reactivity series by using the following phrase, which is, please stop calling me a careless zebra. Instead, try learn how copper saves gold. Then you add platinum at the end. Okay, so you will be seeing that actually we'll see that we will be using these information in a way to solve some of the questions. So let's see the first question. Here the question says that 4 pieces of apparatus shown below are used in a chemical experiment. We have burette, measuring cylinder, pipette, and a thermometer. Question: which statement about the apparatus is correct? A. The burette measures the volume of liquid added in titration. Actually, this is what I've explained at the beginning of this video. So here the right answer is this one. Okay, the burette is actually the apparatus which is used to measure the volume of liquid added in titration. Let's see the other statement. The measuring cylinder measures the mass of substance used in an experiment. This is not correct because the measuring cylinder is measuring volumes of liquids and not the mass of substances. Okay, the pipette measures the volume of gas given in a reaction or given off in a reaction. This is also not correct because the pipette is used to measure volumes of liquids, not the volumes of gases. Then the last one is the thermometer measures the density of a solution, and also this one is not correct because the thermometer is used to measure the temperature. The second question, we have that alcohol and water are completely miscible. This means when mixed together they form only one liquid layer. Question here, which method is used to separate alcohol from water? Is it crystallization, filtration, fractional distillation, or precipitation? So in the course we said that in way to separate miscible liquids we will be using the fact that they will be having different boiling points. So the technique used here is the fractional distillation, okay, by using the fractioning column. So the right answer here is C. In question 3, we have that an experiment is carried out to investigate the rate of reaction when calcium carbonate is reacted with hydrochloric acid. Actually, calcium carbonate, its formula is CaCO3. This is the calcium carbonate. Calcium is group Ca is group 2 element, so it's a cation, positively charged with 2 positive charges. And the carbonate ion is CO3 2 minus. So by combining them to make the ionic compound, we will be combining one calcium cation with one CO3 2 minus anion to form the calcium carbonate, which is a solid. Now, the calcium carbonate is reacted with hydrochloric acid. Hydrochloric acid formula is HCl. Okay, so to give, generally, this will be giving the salt CaCl2, okay, because chlorine anion is Cl minus, so we need two Cl chloride ions in front of one Ca2 plus cation, form the CaCl2, which is an aqueous bond here, plus actually the carbonates in a reaction with acids, they generate CO2, which is a gas, carbon dioxide, plus water, H2O. So here the gas generated during this reaction will be collected. So the volume of carbon dioxide gas given off is measured at different intervals of time. The diagram shows pieces of apparatus used to collect gases. One, downward delivery. Two, gas measuring syringe. Three, over water in graduated tube. And actually in the course we said that for the collection of gas we can use a gas syringe, or we can use a measuring cylinder which is filled with water and inverted in a container of water, which means by displacement of water. So here the right answer will be 2 and 3. These are the two techniques used to collect the gas generated during a reaction. So the right answer is 2 and 3, which means it's B. Now for the fourth question, which two methods can be used to separate a salt from its solution in water? Is it crystallization, decanting, distillation, or filtration? Good. So here we want to separate a salt from its solution in water. So we can do it with two methods. The first one is by using distillation, which means that we will be using a set apparatus for distillation. Then we will be heating the mixture and the liquid will be evaporated, then passing through the condenser, it will change into liquid. Then we can collect the liquid in a conical flask, for example. Then the residue will be the salt. So like this, we can separate the salt from its solution. And also, we can use another technique, which is crystallization, during which we will be heating the solution in a way to remove the water. Okay, for example, by using an evaporating basin, we put in the mixture of the solution and the salt in here and heating it by using a Bunsen burner. So the water will evaporate, and by dipping a glass rod in the solution, if some crystals formed on the tip of the glass rod, we can see that we have a saturated solution. Then we stop heating and we leave the solution to cool. Then crystals will be formed here, and we can then separate between the salt and the solution of water. So the two techniques which can be used are crystallization and distillation, which means 1 and 3. So the right answer here is B. On question 5, we have that sample of dye is investigated by chromatography. A line is drawn across a piece of chromatography paper and the spot of the dye is placed on it. The paper is placed in water. So we have our chromatography paper. We draw a line here and we put a spot of dye. After that, we place our chromatography paper in water. So the question here is, which row is correct? What is used to draw the line? In the course, we said that we use a pencil to draw the line, which means that the right answer here will be either C or D. Now, let's see the position of the spot. The position of the spot should be above the level of water or below the level of water. We said that once we place the chromatography paper here, okay, draw the baseline, which should be, the baseline should be above the water. Then water will be going up through the chromatography paper by capillary effect. So here, the right answer is we will be using a pencil. Then the position of the spot should be above the level of water, which means that the right answer here is C. For the sixth question, one of the instructions for an experiment reads as follows. Quickly add 50 centimeters cubed of acid. What is the best piece of apparatus to use? Is it a burette, conical flask, measuring cylinder, or a pipette? Actually, in the course, we said that the burette and the pipette are apparatus which give accurate volumes and which need precision. So if we want to add quickly 50 centimeters, those two apparatus are not used. Also, the conical flask is not a graduated apparatus. So to measure 50 centimeters cubed of acid quickly, we can use a measuring cylinder. So the right answer here will be C. Question 7 we have. In the chromatography experiment shown, which label represents the solvent front? We have A, B, C, and D. So for C, this is the solvent. Okay, this is the solvent. For B, it's a spot of substance, say spot, and for D, this is the baseline. Then A is the solvent front. This is the solvent front. So the right answer here is A. Good. Let's see now question 8. Chromatography experiments are carried out on four substances P, Q, R, and S. The same solvent is used in each experiment. The resulting chromatograms are shown below as for P, Q, R, and S. The question here is which statement is not correct? Let's see what we have. A. P and Q are pure substances. So let's see. P, Q are pure substances. Actually, this one is correct because the two substances P and Q are showing one spot, each one. They are pure substances. Let's see now B. P and R are different substances. This is correct because they are showing up spots in different levels. This one is here, while for the R, it's in here. So these are two different substances. On C, we have R and S are pure substances. R and S are pure substances. Actually, R is a pure substance because it's showing only one spot, but S is showing two spots, two different spots, which means it's composed from two different substances. So S is not a pure substance, is not pure. And D, S is a mixture of substances. Yes, S is a mixture of substances because it's showing two spots. So which statement is not correct? It's C, because R and S are pure substances. R is a pure substance and S is not a pure substance. It is a mixture. It is a mixture. For the following question, we have that the paper chromatogram below was obtained from four different dyes. The question here is which dye has an RF value of 0.7. The RF is the retention factor. And by definition in the course, we said that the RF is equal to the distance moved by the substance, for example, it's equal to Y, over the distance moved from the baseline till the solvent front, which is the distance moved by the solvent. Let's say that this is equal to X. So the RF, by definition, will be equal to Y over X, and it has no unit, and generally it's always less than 1. So here, to find out which substance has an RF of 0.7, we need to calculate by using a ruler the distance from the baseline till the center of each spot. For example, for A, we will be measuring from here until the baseline. For B, from the center here to the baseline. And for C, we will be measuring from the center of this spot till the baseline. And for D, we will be measuring from the center of the spot till the baseline. And this is the Y distance. And we will be dividing it over the distance from the baseline till the solvent front. Then we compare for each one, which is the retention factor, which is equal to 0.7. And actually, if you do this on your paper, you will find out that the right answer will be D. On question 10, we have diagrams show liquids in a burette and the measuring cylinder. Which row shows the correct reading for the burette and the measuring cylinder? So here we have a burette and we need to find out the reading here and also to find out what is the reading in a measuring cylinder. So here you need to pay attention to these two apparatus because the burette is actually the apparatus used in titration. This is what we talked about before or at the beginning of this video. So by using a burette, you will be opening the stopcock, then the liquid will be drawn to the bottom, which means that the level of the liquid will be diminishing each time you will open the stop. So here, to read the volume in a burette, you will start from the top. You will be reading from the top. While a measuring cylinder is actually the apparatus used to measure volumes. Okay, it's a graduated apparatus, and actually this one you will be filling it with liquid. For example, till here. So all this part here in the bottom will be filled with the liquid. So to read the value of the liquid here, you will start from the bottom, which means you need to start reading from the bottom of the measuring cylinder. So the value here in the burette will be equal to 27, and here you have 27.5, 27.6, 27.7, 27.8. So here the value is 27.8. While in the measuring cylinder, you will be reading from the bottom, which means here you have 30 centimeters cubed, for example. Here you have 40, and between 30 and 40 you have only 5 graduations, which means that each one measures 2. So here you have 30, 40, this one is 42, and this one here is 44. So on the measuring cylinder you read 44, and in the burette you read 27.8. So the right answer will be 27.8 here and 44 here, which means B. Question 11. We have a student needs to measure 22 centimeters cubed of water at 40 degrees Celsius, which means here we need to measure a volume and we need to measure a temperature. Which apparatus is required? Beaker and stopwatch. The stopwatch measures time, and the beaker is not an accurate or is not used to measure volumes. Beaker and thermometer, measuring cylinder and stopwatch, measuring cylinder and thermometer. So here the right answer is clear. You will be using a measuring cylinder in a way to measure the volume, and we will be using the thermometer in a way to measure the temperature. So the right answer here will be D. On question 12 we have mixture is separated using the apparatus shown. Here we have a beaker, we have funnel, and the filter paper. The question here is, what is the mixture? So this mixture used here, what is it? Actually, we said in the course that the filtration is used to separate between a solid and a liquid, which means after separation, we will be having the filtrate, which is the solid, and which is the liquid, and the residue, which is the solid. So let's say this. Aqueous copper chloride and copper. So we know that copper Cu is a solid, but aqueous copper chloride CuCl2, this is aqueous, which means it's dissolved in solution, it's liquid. Or B, we have aqueous copper chloride and sodium chloride. Both are aqueous solutions. Then ethane and methane, these are gases. Then ethanol and water, these are liquids. So the right answer here will be A, because we have aqueous copper chloride. This is the liquid phase, and this one here, which is copper, is the solid phase. Let's see now the theory questions. Question 1. Describe how to separate the following. In each example, give a description of the procedure used and explain why this method works. So here we want to separate copper powder from a mixture containing copper and zinc powders. So what is the procedure and what is the explanation? Good. So here you can see that we have two solids which are mixed together. Copper powder and zinc powder, which are both solids. So here we can use what we studied in the course based on what? For example, sublimation. And actually, no one of them sublime. We can use the magnetic properties, and actually also no one of them is magnetic. So we can use the solubility. So here we need to find solvent which will dissolve one of them, then leave the other as it is. And actually the right solvent here is hydrochloric acid, HCl, or let's say dilute hydrochloric acid. Okay, so generally if we go back to the reactivity series, we will find out that copper is below hydrogen. We have hydrogen here, then below it we have Cu, which is copper. And here we have the most reactive, and here we have the least reactive, which means that copper is less reactive than hydrogen, which means that it cannot displace it from the acidic solution. So this is why copper is not dissolved in hydrochloric acid. If you add a piece of copper solid in reaction, for example, with hydrochloric acid, it will stay as it is. We will be finding Cu solid plus HCl as it is. Nothing will be happening. But for zinc, in the reactivity series, we will find that zinc is here, Zn. It's more reactive than copper. The zinc powder will react with hydrochloric acid. The zinc powder, which is a solid, plus HCl will go into reaction in a way to give ZnCl2. Actually here I need to multiply by 2 to balance the equation, plus H2 gas. The gas or hydrogen gas will be generated. And actually, this salt is aqueous. This is dissolved in the solution. So, by dissolving the mixture, which contains copper powder and zinc powder, only the zinc will be dissolved in HCl to give an ionic compound, to give an aqueous solution. Then the copper will be left as it is. So the procedure here is to add dilute hydrochloric acid, then we filter the solution to separate. This is the procedure, which means here that we will be using dilute hydrochloric acid in a way to dissolve zinc but not copper. And after that, we will be filtering the mixture. Then we will be collecting copper as a residue. Then ZnCl2 will pass as a filtrate. The explanation is because copper does not dissolve in dilute HCl. Zinc reacts to form a salt. So that's it. On the second question, here we have that an important aspect of chemistry is purity and methods of purification. The question, or here we have A list of techniques used to separate mixtures is given below. We have chromatography, diffusion, evaporation, filtration, fractional distillation, and simple distillation. So the question here, from the list, choose the most suitable technique to separate the following. So if we would like to separate water from seawater, so here, as we saw in the course, we will be using simple distillation. Okay. Now, ethanol from a mixture of ethanol and propanol. These are both liquids and actually they are forming a miscible solution. So, to separate between them, we will be using the fractional distillation. Okay, the fractional distillation. Now, iron fillings from a mixture of iron fillings and water. The iron fillings are solid and water is a liquid. So here, to separate a solid from a liquid, we will be using filtration. And the last one, a mixture of two amino acids, which are glycine and alanine. So here, we will be using chromatography. Let's see this question. A list of techniques used to separate mixtures is given below. We have filtration, diffusion, fractional distillation, simple distillation, crystallization, and chromatography. From the list, choose the most suitable technique to separate the following mixtures. A technique may be used once, more than once, or not at all. Let's see the first one. A. Butane from a mixture of propane and butane. Actually, both of them are alkanes, and to separate between them, we'll be using a fractioning column. Means we'll be using the fractional distillation. Now let's see next one. Oxygen from liquid air. So this one also can be separated by using the fractional distillation as this one. Now for the third one, water from aqueous magnesium sulfate. Here we have a salt which is dissolved in water and we want to separate water from it. So we can use the simple distillation. For the next one, we have potassium chloride from aqueous potassium chloride. In this case, we have a solid which is dissolved in a liquid and we want to separate the solid from the liquid. So we'll be using crystallization. Next one, silver chloride from a mixture of silver chloride and water. In here, you need to pay attention that silver chloride, which is AgCl, which is a solid, is actually insoluble in water. Okay, so if we have AgCl plus H2O, this reaction will stay as it is, which means that the products here are AgCl plus H2O. Nothing will be happening. This means that AgCl will stay as it is on its solid form. So to separate between silver chloride from a mixture of silver chloride and water, which means here we have a solid and liquid, we will be using filtration. And the last one is actually glucose from a mixture of glucose and maltose. And this one we will be using chromatography. So this is all for this video. I hope this was helpful for you and also beneficial. Thank you for watching and see you next time. Goodbye for now.